हेलो एवरीवन, नमस्कार, हाउ आर यू, कैसे हैं आप लोग? राइट, होप यू आर प्रिपेयरिंग वेरी वेल. Now it's time to discuss the revision, that is another revision session for the electrical for GATE 2020, right? That is for the signal and system. Now, that is a brief idea about me, no need to discussion for that. Yes, total number of days left for the electrical GATE exam is only 9 days. Just prepare according to that, right? One thing more I have to convey, that is the mega mock challenge for the electrical is Gradeup is basically going to conduct on 5th of Feb, that is at 12 p.m. right, to 6th Feb 12 p.m. So registered yourself, and that is the description given in the below, right? Kumudni, good evening. Shiva Prasad, hello dear, right? Right, now for the next, one thing more, your exam of the GATE exam for the electrical is going to be held on the 8th of February, and on the same day, 8th of the February, we are going to analyze at the 5 p.m. we are going to analyze the detailed analysis of the GATE paper, right? Harshal, hello. In this paper, we are going to discuss the answer key, in the analysis, we are going to discuss the answer key, weightage analysis and the expected cutoff, right? Now in this class, in the previous, some of the student in the yesterday class asked about the Fourier transform to discuss. So in this class, we are going to discuss the few questions related to the Fourier transform and the property, that is the basically very important property regarding to the Fourier transform, right? Harshal Wade, hello. Sushant, signal and system is the same for the EC and E. Yes, almost the same, but E having the vast syllabus and the signal system. EC student also you have to study the DFT, FFT, DTFT, FIR filter, IR filter in the signal and system, right? But that portion is not mentioned in the electrical syllabus. Now, my dear friend, for the continuous time Fourier transform, if you want, the Fourier transform formula in the omega is nothing. Fourier transform is just a tool by which we can convert the time domain signal into the frequency domain signal, right? That is the formula in the omega. F of integration of minus infinity to plus infinity, f of t e raised to power minus j omega t dt. And inverse CTFT having the formula 1 upon 2 pi minus infinity to plus infinity, f of omega e raised to power plus j omega t d omega. If you want to find out in the f, then in the f, replace the omega with the 2 pi f, then the formula will become x of t e raised to power minus j 2 pi f t dt. And in the inverse Fourier transform, there is no need to use 2 pi here, right? That is the basically difference. एग्जाम को फोड़ना है, डेफिनेटली निर्मल कुमार, एग्जाम को फोड़ना है और बेटा फोड़ के ही रहेंगे किसी भी तरीके से, राइट? Now, my dear friend, the first question I'm asking about this one, that is the basic thing, right? Because we can expect this type of question, that is the sampling question in the Fourier transform. 4 properties basically very, very important, right, for the Fourier transform. First, duality. We can expect the question on the duality. Second one property for the Fourier transform is the important, that is integration property. Third property is the important, that is scaling property. And fourth one is the time differentiation property. Right, time differentiation and frequency differentiation also, that is a very, very important, right? Yes, DTFT is a very few things, because if you know the CTFT, the DTFT is also important, but that is not that much of extent. But yes, DTFT also mentioned in the, right? Now, yes, time differentiation, and the fifth one is the energy. Energy and ESD, energy spectral density. These are the basic important property. We can expect this question of the Fourier transform from this topic, right? Now, first I am giving you the question, the Fourier, find the Fourier transform of this function. Yes, Shiva Prasad, your answer is correct. It is a gate pulse or rectangular pulse. You can write this function like this: 1 RECT also t divided by t. Either you can use this notation or use the gate pulse notation. If you want to find the Fourier transform of this function, that is the short approach. Just take the area, that is the Fourier transform of this function is nothing. It is a t sampling omega t by 2. that is in the omega. But if you want to write in the frequency, then the Fourier transform of this t sinc ft. So my dear friend, always remember in the form of the sampling as well as in the form of the sinc. In the both the case, that is important. And generally in the gate paper they are asking in the terms of what? In the terms of the sinc function. So just remember these things. It is a very useful, right? How to find out? Just remember what is the area of this function. Sir, area of this function is nothing. It is just a t. Area of this function is t. So t sampling omega, because we are converting to the frequency domain, and it is the total width is t. So total width divided by 2, we'll get the answer. For example, if I'm giving you one question, what is the Fourier transform of this function? -5 to 5 and 2 in time domain. What is the Fourier transform of this function? Very easy मेरे दोस्तों, बहुत ही easy है. Area निकालना है. What is the area? 10. 10 into 2, 20. So area sampling omega, right? Omega, total width divided by 2. Total width is 10 divided by 2, 5. That is the answer. But if you want to write in the frequency domain, right, in the f actually, hertz, then it will become 20 sinc f, and total width we have to mention. So total width is 10, so the answer is 10. 10f. So this is basically the actual answer to solve this function, right? Everybody, are you getting my point? Tarun Gupta, correct. बेटा t नहीं आएगा, बेटा t नहीं आएगा, थोड़ा सा गलती कर दिया तरुण. We do not write t here because it is in the omega itself, right? Now, for the next question, if I want to write, that is called triangular function, right? Triangular function. And what is the total width? The total width is 2. If you want to write the Fourier transform of this function, then Fourier transform of this function is nothing, मेरे दोस्तों, it is t sampling square omega t by 2. What is the short approach to find out the Fourier transform of this type of function? Very easy, right? What is the area of this triangle? Sir, area of this triangle is nothing, it is just a what? T, right? If you find the area of this area, it is called t by 2. And this side also t by 2, so total area will become t. So just make the magnitude t. After that, sampling square, because it is in omega frequency domain, that's why I'm using omega. Total width is what? 2t. So total width divided by 4. Total width divided by 4, then it will become t by 2. Just take the example. Direct short approach. Sir, what is the Fourier transform of this function? -5, 5 and 2. It is f of t. If I'll ask, what is the Fourier transform? मेरे दोस्तों, what is the Fourier transform of this function? व्यास. Oh, Chandan sir, यहाँ पे भी. वाह जी वाह. व्यास, thank you, right? Now, if you want to find out the Fourier transform of this function, then the Fourier transform is nothing. First, find the area of this function. Area of this triangle is nothing, 10. Total, 5 this and 5 this. So 10. So I'm writing 10. Sampling square, omega. Total width, 10 divided by 4. 10 divided by 4. Right? That is the answer. So my dear friend, we can directly form the Fourier transform of this function. Yes, Tarun Kumar, your answer is correct. Right? Sampling square, omega into 2.5. Yes, your answer is correct, right? Now, just remember few property that is a very important for the short, just a revision class. It is just a revision class, right? So my dear friend, for the properties of the Fourier transform, let's suppose f of t having the Fourier transform f of omega, right? F of t having the Fourier transform f of omega, then time shifting t minus t naught. Then if minus is used, we have to use multiplied with e raised to power minus j omega t naught. If plus is used, we have to use plus j omega naught. Minus to minus, plus to plus, right? बस इतनी सी चीज याद रखनी, right? That is the time shifting. Now frequency shifting, इसमें उल्टा. If f of t having the Fourier transform f of omega, if f of t having the Fourier transform f of omega, and if we are shifting the f of omega by minus omega, then here minus, so we have to use plus e raised to power plus j omega naught t, and here plus, then we have to use plus, then we have to use minus j omega naught t. Very easy, not that much of tough, right? Reversal property. F of t having the Fourier transform f of omega, then if you are replacing the t with minus t, then of course the omega will be replaced by minus omega. Very easy, right? Now scaling property, important property, right? if f of t having the, after that we'll do a lots of question related to Fourier transform और देखते हैं आपको कितना आता है Fourier transform, वो चेक भी करेंगे, right? Scaling property f of t having the Fourier transform f of omega. Now what about the Fourier transform f of at? Sir, scaling is basically performed. So omega will be replaced by omega by a and the magnitude will be 1 upon mod a, right? If f of t having the Fourier transform f of omega, if I'll ask what is the Fourier transform f of a omega, 1 upon mod a f of t by a, right? We'll do a question on this property also, right? We'll do some question. Time difference is f of t having the Fourier transform f of omega, the df of t by dt having the Fourier transform, then just multiply with the g omega in the frequency domain. You'll get the answer, right? दो बार करोगे 2 times g omega square, we should multiply, right? Frequency differentiation. If f of t having the Fourier transform f of omega, right? If t is multiplied in the time domain, then in frequency domain we have to differentiate the function with omega. पर इतने से काम नहीं चलेगा दोस्तों. We have to multiply it with j also, right? Then you will get the answer, right? So whenever the f of t having the Fourier transform f of omega, and when t is multiplied with the time domain, then in the frequency domain we have to differentiate the function with the omega, and after that we have to multiply it with j. Then you will get the correct option, right? Now the time integration property. We can also prove this property, but at this moment no need for the practice, no need for the derivation, because the remembering of this thing property is very required, right? So if you will integrate the any function from minus infinity to t, then the answer will be pi f of 0 del omega plus f of omega upon g omega. That is the important. We have already discussed, this one is the important property, right? याद रख लो, बहुत काम की चीज है और होप आपको सब याद होगा. ब्रशअप हो रही है चीजें, बहुत ही बढ़िया. फ्रीक्वेंसी इंटीग्रेशन, राइट? सो माइनस इंफिनिटी टू ओमेगा नॉट इफ यू वांट टू इंटीग्रेट, देन द टाइम डोमेन 1 by t is basically divide, right? So in the time domain, if you are dividing the t, in the frequency domain we have to integrate it, right? Now my dear friend, area property, it is also very important, right? If f of t having the Fourier transform f of omega, अगर f of t का Fourier transform f of omega है और मैंने पूछा कि बताओ जल्दी एकदम जल्दी बता दो कंप्लीट इंटीग्रेशन एरिया ऑफ दिस फंक्शन, इट इज जस्ट लाइक f of 0. In the frequency domain, the magnitude at omega equal to 0 is basically give you the answer, right? And now if you will integrate in the frequency domain, complete integration, right? Running integration d omega, then it will be equal to 2 pi into f of 0. टाइम डोमेन में जो t इक्वल टू 0 पर जो वैल्यू होगा उतना ही नहीं, उसको 2 pi से मल्टीप्लाई भी करो, then only you will get the answer, right? Now we are moving on the next, right? Duality, very interesting topic, right? Very just remember one thing, बहुत ही इंटरेस्टिंग है, बिकॉज डुअलिटी थ्योरम आप लगा ही तब सकते हो जब आपको फोरियर ट्रांसफॉर्म पहले से ही पता हो, राइट? दैट्स व्हाई इट इज अ वेरी इंपॉर्टेंट. इफ आई एम सेइंग f of t हैविंग द फोरियर ट्रांसफॉर्म f of omega, तो बेटा उसके अंदर होता क्या है कि कुछ फंक्शन को हम टाइम में जानते हैं और कुछ फंक्शन को हम फ्रीक्वेंसी में जानते हैं. वी नो दैट लॉट्स ऑफ फंक्शन वी नो इन द टाइम डोमेन एंड लॉट्स ऑफ फंक्शन वी नो दैट इन द फ्रीक्वेंसी डोमेन. फॉर एग्जांपल सर, व्हेनेवर द रेक्टेंगुलर पल्स इज गिवन, द रेक्टेंगुलर पल्स हैविंग द फोरियर ट्रांसफॉर्म f of omega. तो बेटा ध्यान रखो, कुछ फंक्शन को हम टाइम में जानते हैं, कुछ को जैसे सैंपलिंग आया, वी नो दैट द सैंपलिंग फंक्शन ओनली इन द फ्रीक्वेंसी डोमेन, राइट? अब होगा क्या, वो देगा धोखा. वो क्या देगा बेटा? धोखा. कैसे धोखा देगा कैसे? जहां पर ओमेगा लिखा है, राइट, हमको फ्रीक्वेंसी में जो फंक्शन पता है वो ओमेगा की जगह पुट कर देगा टी, राइट? हम फ्रीक्वेंसी में जानते थे उस सिग्नल को, बट उसने ओमेगा की जगह क्या कर दिया? रख दिया टी, मतलब हमको दे दिया धोखा. और जब हमको मिलता है धोखा तो बेटा धोखे पर क्या देना है? धोखे पे देना है एक और धोखा और उसके ऊपर एक और धोखा. एक धोखे का जवाब दो धोखे से. f of t having the Fourier transform f of omega, अगर उसने ओमेगा की जगह टी पूछ दिया और उसने आपको दिया है धोखा, तो आपको बेटा धोखे का जवाब दो धोखे से. कैसे? इस टी की जगह पुट कर दो माइनस ओमेगा, और खाली इतना ही नहीं, ये तो एक धोखा हुआ, दूसरा धोखा जस्ट मल्टीप्लाई बाय 2 पाई. तो एक धोखे का जवाब दो धोखे से. इज इट क्लियर? रमाना कुमार, गुड इवनिंग डियर, राइट? सो इट इज द ड्युअलिटी प्रॉपर्टी, राइट? नाउ टाइम डोमेन कॉन्वोल्यूशन. Whenever the signal, time domain, the signal is convolute, in the frequency domain, the signal is multiplied. We know that. And vice versa. Whenever the frequency domain is convolute, then the time domain, it is multiplied. Right? one time domain multiplication property, then frequency domain we have to convolute 1 upon 2 pi. And energy, just remember, if f of t having the Fourier transform f of omega, if f of t having the Fourier transform f of omega, good evening Rajshekhar, right? Parichay, good evening dost, right? Now f of t having the Fourier transform f of omega, now take the mode of f of omega in the frequency domain and then square it. This value is called ESD, energy spectral density. Energy spectral density, right? So beta, whenever they are asking about the ESD, जब भी कभी वो पूछ ले कि, right? राजकुमार, good evening, right? कभी भी अगर आपसे वो पूछ ले कि ESD क्या है, एनर्जी स्पेक्ट्रल डेंसिटी है, कुछ भी नहीं करना बेटा, कुछ भी नहीं करना है. टाइम को फ्रीक्वेंसी में कन्वर्ट करो, फ्रीक्वेंसी में मिला, मोड लो, स्क्वायर करो, वही ESD कहलाता है, राइट? एंड व्हाट इज द यूनिट ऑफ ESD? सर, जूल पर हर्ज. पर यूनिट बैंडविड्थ द एनर्जी इज डिस्ट्रीब्यूटेड इज कॉल्ड ESD, energy spectral density, right? And yes, that is called energy spectral density. And if you want to find out the energy, then find the minus infinity to plus infinity mode of f of omega whole square d omega 1 upon 2 pi. You will get the answer of the energy, right? So there is the one approach, and the second approach minus infinity to plus infinity f of square dt. You will get the answer by this approach, because area under square of the function is called energy. Frequency domain also there will be the same thing, right? Now we are moving on the next, right? Autocorrelation function. If f of t having the Fourier transform f of omega, if f of t having the Fourier transform f of omega, just take the mode of f of omega and square it. It is called what? Sir, it is called ESD, energy spectral density. Take the inverse Fourier transform of this function. ESD inverse Fourier transform. The inverse Fourier transform of the energy spectral density is nothing. It is called autocorrelation function, ACF. तो बेटा जब भी कभी ACF calculate करना, whenever you want to calculate the ACF, autocorrelation function, just take the what? Just find out the ESD and then take the inverse Fourier transform of this function. You will get the what? You will get the autocorrelation function, right? And one thing more, autocorrelation function having the magnitude at t equal to 0 is called energy. So बेटा ऑटो कोरिलेशन फंक्शन का t equal to 0 पर जो मैग्नीट्यूड होगा दैट इज कॉल्ड एनर्जी. यस, तरुण कुमार इज आस्किंग वन क्वेश्चन. सर, सैम्पलिंग के क्वेश्चन आते हैं क्या? बिल्कुल आ सकते हैं दोस्त इलेक्ट्रिकल में, राइट? बिकॉज इट इज मेंशन इन द सिलेबस ऑफ द सिग्नल एंड सिस्टम, राइट? बिकॉज इन द गेट क्वेश्चन rarely I seen the question, but in the test series there are lots of question asked based on the sampling Nyquist rate. So it's important. That is not a typical topic. It is a very easy topic. In this class, I'll give you the concept related to the sampling. Don't worry. There's the baseband sampling and the band pass sampling. Both the concept I'll give you. Tarun Kumar, don't worry. Right now, yes, it is also important because we can expect in this type of question also, right? If x of t having the Fourier transform x of f, right? X of t having the Fourier transform x of f. If the x of t is real and even, then x of f is always real and even, right? Real and even, frequency domain also real and even. If the time domain it is imaginary and even, then in the frequency domain it is also imaginary and even, right? In the time domain it is real and odd, then in the frequency domain it is imaginary and odd, right? I think you all are aware, it is a very important chart. It will give you the brief idea about the Fourier transform, right? Real और odd है तो इधर imaginary और odd होगा, imaginary और odd है तो इधर real and odd होगा, right? Complex and even, complex and even, complex and odd, complex and odd in the frequency. Conjugate symmetric in time domain, in the frequency domain it is a real. In the x of t conjugate anti-symmetric, then in the frequency domain it is the imaginary part, right? If the x of t is only real, right, then it follow the conjugate symmetric. Real but neither even nor odd, then it follow the conjugate symmetric. If real, if imaginary but neither even nor odd, then conjugate anti-symmetric. So this type of, right, abhi official good evening dost, this type of table you should remember. Just take the snapshot for the particular this one. It will helpful to solve this question, right? और बहुत कम लोग बेटा, only 43 people are watching, right? And live तो only 14 people basically like this session, right? Just like this session, like करो बेटा please, और उसके बाद क्वेश्चन सॉल्व करें. पहले लाइक करेंगे फिर क्वेश्चन सॉल्व करेंगे. Everybody, okay, one question in front of you, one question in front of you. बोला मैंने only 3 people like this session, right? 14 था, 17 हुआ है. Cheater. चलिए solve करिए इस question को. Just solve this question. Let x of t having the frequency domain that is x of j omega, right? Be the Fourier transform here. The Fourier transform of the signal x of 5t minus 3 in the terms of x of j omega is given as. Can anybody give me the answer for this question? Tarun Gupta, very good. Excellent, Tarun. Rajat Kumar Singh is also giving the answer. Very good, Rajat. Anybody else? Can you give me the answer for this question? Datta Kumar, very good. A. Shiva Prasad, A. Abhi, B. Abhi, तुमने B कैसे दिया बेटा? सब A जा रहे हैं. Omega Techno Solution. Sir, please explain. Okay, this question or previous one. Previous beta, I cannot explain this one actually. Just take the snapshot because if I'll explain it, it will take lots of time. By the example, I can explain each and every topic. So it will take lots of time. Just take the snapshot. Mind rewind. बहुत ही बढ़िया mind rewind. गिरधारी प्रधान A. Very good. Okay, for this question, if you want, everybody is giving the correct option for A, right? How you can solve this? Sir, we know that x of t having the Fourier transform x of omega, right? Now, my dear friend, they are asking about, if I am asking, what about the Fourier transform of x of t minus 3? Then the Fourier transform is nothing, it is just a x of omega is multiplied by e raised to power minus, इधर minus तो इधर भी minus, j omega 3 और minus j 3 omega, right? That is in frequency domain. Now x of scaling कर दिया t की जगह, then we have to multiply 1 by 5 omega और j omega है तो j omega will replaced by 5, right? E raised to power minus j 3 by 5 omega. So it will be the option in what? It is the option in the A. So everybody is giving the correct option. Excellent, my dear friend. बहुत ही बढ़िया, right? हर्षल बेटा ऐसे क्वेश्चन में भी गलती करोगे तो कैसे काम चलेगा बताओ? There will be the preceding order, na? Precedence rule. By the precedence rule, whenever the shifting, scaling and reversal are given, first of all we have to do what? Shifting. After that scaling. After that reversal. Sign थोड़ा गलत दिखा नहीं. Okay, कोई इशू नहीं, कोई इशू नहीं. Sir, same model में Cn क्या होगा? It's very confusing. Cn, okay, that in the Fourier series. There will be the trick also with the 2 pi multiplication. You will get the what that option, right? Right. Now we are moving on the next. बेटा PDF वाला ये Gradeup की team decide करती है. That is decided by the Gradeup. That is not decided by me, right? Compression in the frequency. Okay. Smriddhi Soni. One domain compression gives the another domain expansion. Just take the example. Whatever you are taking the example, right? If I am taking the example like this, any example you can take. In the any example you can take, you can find this like this, right? We are moving on the next question, but yes, definitely I'll give you the answer for this, right? Samriddhi, don't worry. After some time, I'll give you the answer for this. Okay, can anybody give me the answer for this? If the x of t equal to sin t upon pi t, convolute with sin t upon pi t. Signal with this donating the convolution operation. Hence the x of t is equal to, can anybody give me the answer for x of t? Shiva Prasad is giving the answer A. Very good. Dev Kumar is giving the answer D. Very good. Now there will be the confusion between Shiva Prasad, 100% is giving the answer A. Okay. Srinu, everybody just give me the answer for this question यार. और थोड़ा सा क्वेश्चन सॉल्व हो रहा है तो थोड़ा लाइक भी कर दो सेशन को, राइट? अजय कुमार ए इज 100%. ओह, देखते हैं अगर 100% ए है, एक 100% ए बोला है, दो जने 100% ए बोले, राइट? माइंड रिवाइंड ए, एवरीबडी इज गिविंग द करेक्ट ऑप्शन. ओके, एक्सीलेंट एक्सीलेंट. सचिन कुमार ए इज द करेक्ट. यस यस, जस्ट लुक एट द फंक्शन. साइन टी अपॉन pi t, I want to calculate the Fourier transform of this function, right? Sir, I don't know the Fourier transform of this function, but we know that 1 upon pi sin t by t, I can say that this function is nothing, it is just a sampling function, sampling t, right? Now, my dear friend, whenever I am asking what is the Fourier transform of the sampling t, can anybody give me the answer, the Fourier transform of the sampling t? Can anybody give me the answer? कि what is the Fourier transform of the sampling t? What is the Fourier transform of the sampling t? Sir, we don't know, right? Yes, rectangle pulse. But sir, we don't know what is the Fourier transform of this function. Sir, ये cheating हुआ है, धोखा दिया गया फिर से. Sir, sampling is the function which we have seen in the terms of the omega. But it is given in the terms of t. Just remember, sir, अगर वो ऐसा पूछता, if they will ask like this, minus t by 2 to t by 2, this one, that is 1 g of t, then we can say that कि Fourier transform of this function is nothing, it is just a t sampling omega t by 2. Sir, then only we can say that the Fourier transform of this function is t sampling omega t by 2. Now look at this one. अगर वो दे दे धोखा, how they can give you the धोखा with the replace or what? They can replace the omega with t. अगर उसने t sampling omega की जगह दे दिया t by 2, अगर बेटा उसने ओमेगा की जगह दे दिया ये डुअलिटी, सर ये हो गया धोखा. और धोखा अगर सर वो धोखा दे देता, देन वी कैन से दैट धोखे पे देना है धोखा और उसके ऊपर एक और धोखा. तो क्या करना है सर, हमको कुछ नहीं करना है, इस फंक्शन को 1 g ऑफ t, इस t की जगह धोखा दे दो सर आप भी माइनस ओमेगा, और इसने एक धोखा दिया, हम दो धोखा देंगे, मल्टीप्लाई बाय 2 पाई, राइट? एक धोखे का जवाब दो धोखे से. नाउ दे आर नॉट आस्किंग लाइक दिस, दे आर आस्किंग व्हाट? सैंपलिंग t फोरियर ट्रांसफॉर्म. सो मेरे दोस्तों t by 2 चाहिए ही नहीं. So if you do not require that t by 2, make the t by 2 1. So that t will become what? 2. Now just replace the t with 2, then you will get, if you replace the t with 2, 2 sampling t having the Fourier transform 2 pi, g की जगह लिख दिया क्या 2, and of course the gate pulse is nothing, it is just a even function. If the gate pulse is a even function, minus omega represented by omega, and it is looking like this. -1 से लेकर 1, magnitude is 2 pi, but 2 will be cancelled out because we want only sampling t. Then sampling t having the Fourier transform pi g of 2 omega, it will become pi. It is the frequency domain, right? Everybody, are you getting my point? Yes, Shiva Prasad, your answer is correct. Now, so we know the Fourier transform of this function. We know the Fourier transform of this function is nothing, it is just like this. -1 to 1, and it is pi. Right? It is looking like this. Now, my dear friend, we have to convolute these two signals. So, time domain convolution gives the frequency domain multiplication. So, we have to multiply this signal with itself. We have to multiply the signal with itself, right? Because time domain convolution gives the frequency domain multiplication. Right? भूषण कुमार सर हिंदी में बता दीजिए बेटा, मेरा भी बहुत मन करता है. Right? टाइम डोमेन का कन्वोल्यूशन बेटा क्या होगा? फ्रीक्वेंसी डोमेन में ये ओमेगा में दिख गया, ये ओमेगा में दिख गया. अब मुझे इन दोनों को मल्टीप्लाई करना है. इफ यू विल मल्टीप्लाई द मैग्नीट्यूड विल चेंज एंड ऑल अदर थिंग्स विल रिमेन सेम. सो माय डियर फ्रेंड, फॉर दिस फंक्शन, ओके, 1 by pi is also multiplied ना, so it will become 1, it will become 1 upon pi t. It will become, now if you will multiply, the answer will be looking like this. और जैसा कि शिवा प्रसाद ने बताया कि सर 100% श्योर, और एक और बच्चा था जो 100% श्योर था, वो गायब हो गया, वो दिख नहीं रहा है. राइट? Symmetric about yes, y axis. So it will again looking like this. If it will looking like this, sir, it is nothing, because if you will multiply with it, you will get the answer like this, right? So my dear friend, if you want to solve this function, it is again the same function, and the answer of the Fourier transform of this function is nothing, it is just a what? Of course, the Fourier transform you have to calculate, it is looking like this, the same function, right? That is 1 upon pi sin t by t, that is nothing, it is just a option. Everybody is giving the correct option. Excellent मेरे दोस्तों, बहुत ही अच्छी प्रिपरेशन चल रही है और कंसेप्ट आपके स्ट्रांग है, ये तो मुझे पता चल रहा है. और यही कंसेप्ट स्ट्रांग होने पर एक और क्वेश्चन आपके लिए चवन्नी भर का क्वेश्चन. कैन एनीबॉडी गिव मी द? सर आई एम अवेलेबल. ओ अजय कुमार, यस, अजय ने एक सही आंसर दिया था और 100% श्योरिटी के साथ दिया था. एक्सीलेंट. दैट टाइप ऑफ कॉन्फिडेंस वी कैन रिक्वायर्ड और वी शुड हैव इन द गेट एग्जाम. नहीं तो गेट में होता है कि बेटा देयर विल बी लॉट्स ऑफ कंफ्यूजन कि ए लगाऊं बी लगाऊं, फिर करते हम अक्कड़ बक्कड़ बम्बे बो और फिर गलती हो जाती है. सो थोड़ा सा कॉन्फिडेंस, और कॉन्फिडेंस उसी में आता है जिसके कंसेप्ट क्लियर हो. तो अजय बहुत ही बढ़िया, राइट? और जिन्होंने भी आंसर ये दिया था, एक्सीलेंट. नाउ जस्ट गिव मी द आंसर फॉर दिस क्वेश्चन. सर फ्रीक्वेंसी रिस्पॉन्स ऑफ एलटीआई सिस्टम इज गिवन, द स्टेप रिस्पॉन्स वी वांट एक्चुअली. सो फर्स्ट वी हैव टू कैलकुलेट एच ऑफ टी. यस, कविता इज गिविंग द आंसर बी. ओमेगा टेक्नो सॉल्यूशन इज गिविंग द आंसर बी. Shiva Prasad is giving the answer B. in the app nobody is responding, only 8 people are watching in the app, right? और जो देख रहे हैं, जो आंसर दे रहे हैं, शिवा प्रसाद वेरी गुड, जो आंसर दे रहे हैं वो लाइक नहीं कर रहे हैं, पर सही बता रहा हूं, everybody should like this session. Sachin Kumar, you all excellent. Sachin, your answer is correct. Everybody is giving the correct option. First we have to calculate, sir, we know that if e raised to power minus at u of t I am giving, then the Fourier transform of this function is nothing, it is just a 1 upon a plus j omega, right? It is 1 upon a plus j omega. So my dear friend, if I am writing, and omega we know that 2 pi f, so I am writing 1 upon a plus j 2 pi f. You will get the answer like this in the frequency domain, right? After that I'll use the duality principle, but just remember this one. So if e raised to power minus, I'm writing at the place of 5, a I'm writing 5, right? So this will become nothing, 5t dot ut, then the Fourier transform nothing, it is just a 1 upon 5 plus j 2 pi f, right? Now in the function I'm just taking the, or right, this is basically the answer for this function, right? E raised to, that is 1 upon 5 right now. Now मेरे दोस्तों मैं कर क्या रहा हूँ, we are just dividing a numerator. Okay, we do not require the 5, so I am dividing the function with 1 by 5. You will get, and we have to take the 5, so we have to take the common and we have to multiply the function with 5. So if you multiply the function with 5, you will get the answer like this, right? But we want what? We want this one. We want this one. So अब मुझे बताओ कि यहाँ पे मुझे 5 यहाँ पर भी चाहिए, और अगर मैं मुझे 5 यहाँ पर भी चाहिए तो मैं कैसे ला सकता हूँ 5? सर 5 लाने का एक ही तरीका है, सर डिनोमिनेटर और न्यूमरेटर दोनों में एक चीज़ से मल्टीप्लाई कर दें, और वो किस से? 10 लाना है तो 5 से मल्टीप्लाई 5 से. सो इन द न्यूमरेटर एंड डिनोमिनेटर वी आर मल्टीप्लाइंग विद 5, और यहाँ पे 1 भी चाहिए. सो फर्स्ट आई एम डिवाइडिंग, ओके 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 ओके, that will become, I am taking the 5 as a common in this, then it will become 5 upon 1 by 5 plus j 2 pi f. I am taking the 5 common. So my dear friend, a is nothing, it is just a 1 by 5. So a person who is giving the answer, just remember, this is not a like this. This function is basically looking like this. We have to take 5 as a 5, or 1 by 5 is the basically a. So I am writing e raised to power minus 1 by 5 t u of t, having the Fourier transform 1 upon a की जगह मैंने लिख दिया 1 by 5 plus j 2 pi f. Now I am taking the 5 common or multiplying the numerator and denominator by 5. You will get the answer 1 upon 1 plus j 10 pi f. So this function having the Fourier transform e raised to power minus 1 by 5 ft ut. Now we have to integrate it. So my dear friend, if you will integrate it, minus infinity to t e raised to power minus 1 by t, right? So it will become 0 to t dt. The answer will become e raised to power minus 1 by 5 upon 1 by 5 minus, and limit will be between 0 to t. So minus 5 e raised to power minus 1 by 5 t minus 1. Again minus common 5, 1 minus e raised to power minus 1 by 5t. So the answer is nothing, it is just a B is the correct option, right? Everybody is giving the correct option. Excellent. Sir, when two rectangular pulse duration t, then we get triangular pulse. Triangular pulse will get only when you will convolute it. But in the previous question we are not convoluting, because in the time domain they are convoluting, in the frequency domain it is just a multiplication, right? Yes, it can also done by the Laplace also, yes. But just remember one thing, we cannot put s equal to j omega everywhere, because s equal to j omega we can put only when the function is stable. If I'll ask you one question, what is the Fourier transform? What is the Fourier transform of u of t? We know that the Laplace transform of the u of t, nothing, it is just a 1 by s, right? But if I'll ask you what is the Fourier transform of this function, then we cannot say 1 upon j omega by only replacing the s upon by 1 j omega. So this method is not applicable. So we cannot apply anywhere. You are putting just s equal to j omega, right? Because what is the Fourier transform of u of t? So it is pi del omega plus 1 upon j omega. It is the basically answer. Pi del omega plus 1 upon j omega is the answer. Are you getting my point, Tripti? right? Region of convergence matters. So yes, Tarun, excellent. Right, now for the next question in front of you, everybody. In the app, there will be the option after the session, but in the YouTube during the session you can like the session, right? Okay, one more question in front of you, everybody. Just give me the answer for this question. Take care of the impulse. Yes, Shiva Prasad. Right? Parichay, in the time domain that function was impulse response. In the time domain that function was impulse. If the time domain the function is impulse, then in the frequency domain the impulse having the Fourier transform, if you want, then it is nothing, it is just a 1. But in the 1, if you want to find the Fourier transform, then it is just not a del of omega, it is 2 pi del of omega. Because in the inverse Fourier transform in the Fourier transform, in the omega, there will be the relation between 2 pi. But yes, if you are writing in the frequency domain, del of t having the Fourier transform 1 in the f, 1 having the Fourier transform del of f, then it will be applicable, right? Right, everybody, yes, everybody giving 2 pi del, yes, correct. So my dear friend, just remember, g of f is the represent the Fourier transform of a signal g of t, which is of real. Okay, function is given real and odd. If the function is given real and odd, of course it is a pure imaginary and odd in nature. So g of f is pure imaginary and odd in nature. Pure imaginary, okay, only B is option matching, right? Only B is the correct. G of is the pure imaginary and yes, odd in nature also. You can add that is odd in nature. So this type of prop question we can also expect, but this type of not that much of easy question. मिलता जुलता हम सोच सकते हैं. Sin omega t is an example of the real and odd. Okay. Now, for the next question, can anybody give me the answer for this question? Right, Sachin, your answer is correct. Sonu, for the previous question, your answer is correct. Right? Can anybody give me the answer? आंसर दो बेटा फटाफट. संतोष कुमार साहू, हेलो दोस्त, कैसे हैं आप? राइट, भानु प्लीज -90 डिग्री. भानु फेस प्लस और -90. आई एम नॉट गेटिंग. राजकुमार, आई एम नॉट गेटिंग. राजकुमार, गुड इवनिंग सर, फ्रॉम हितेश. ओके, हितेश, हाउ आर यू? राइट, everybody is giving the answer C for this question. Few person is giving the answer B. Right? Okay. If you want to solve this question, देखते हैं क्या आंसर आता है. और मुझे तो इस क्वेश्चन को सॉल्व, मुझे नहीं लगता कि ज़्यादा टिपिकल क्वेश्चन है. See, using the duality. Yes. We have to use only the duality, right? संतोष कुमार, good evening, right? So मेरे दोस्तों, we know that just read the question carefully. The function f of t has the Fourier transform g of omega. The Fourier transform of g of t is, right, we have to find out the Fourier transform of g of t, right? So f of t having the Fourier transform g of omega, f of t having the Fourier transform g of omega, right? Now we have to find out the g of t. So of course by the duality theorem 2 pi should be multiplied and minus omega. So of course the answer is nothing. C is the only by the that is only by the duality theorem. सीधा duality लगा दो, आंसर मिल जाएगा. आपको इनवर्स में जाना है ना. सो अगर g की जगह ओमेगा की जगह t पूछ लिया और आपसे ये आंसर पूछ लिया कि इसका क्या होगा, तो आपको कुछ नहीं करना है. क्या करना है? 2 पाई और इसमें f की जगह क्या पुट करना बेटा? माइनस ओमेगा. यू विल गेट द आंसर. राइट, अभिषेक शर्मा. राइट, नाउ वन मोर क्वेश्चन टू यू. राइट, कैन एनीबडी गिव मी द आंसर फॉर दिस क्वेश्चन? एनीबडी कैन गिव मी द आंसर फॉर दिस क्वेश्चन? एवरीबडी जस्ट रिस्पॉन्ड. राइट, जल्दी से रिस्पॉन्स कर दो बेटा for this question, everybody. Everybody is giving the answer C for this. Okay. What is the basically nature? Sir, it is the reverted. So of course the minus sign we should apply. In the every option the minus sign is basically given. Sir, it is the width is 4 and this is the width 2. So of course the compression is given by 2 factor. So time domain compression in the frequency domain multiplication. So we have to write this function, it is the x of t actually. So my dear friend, y of t is nothing, it is just a what, if you want to write, just compress it or just shift it and after that compress it. I am just shifting this signal to 2, then it will be looking like this. 0 to 4 minus 4 and this will be minus 2, right? If we'll shifting, it is x of t plus 2. It is x of t plus 2. Everybody, are you getting my point? And now we are compressing, then it will become what? X of t ki jagah 2t put kar do beta. Then it will become what? It will become like this. It is minus 1, 0 and minus 2. And negative sign we have to add, right? Option D and A are same, I think. Oh, yes, both are the same. No. D and A have the different, na? Here minus 1 by 2 is multiplied, here 1 by 2 is not multiplied, right? How can you say that it is the same? So y of t is nothing, my dear friend, minus x of 2t plus 2. So if you want to solve this function and the Fourier frequency domain, then it will become x of first omega, if you are writing in the f by 2, compression 1 by 2, and the shifting e raised to power minus j 2 pi by f, so or 4, so divide by 2, so it will become what? 2, so minus, so we have to use minus sign j 2 pi f. So the answer is nothing, answer is what? Can anybody give me the answer for this question? D and C are same. Okay, just look at this once again. Just look at this one. If you want to solve this question, x of t having the Fourier transform x of omega, x of t plus 2 having the Fourier transform x of omega dot e raised to power, if we have to use plus, then plus j or 2 pi f, so j 2 pi f, right? And 2, so 4 pi f. It is the answer. Now x of 2t plus 2, so it is f, right? It is f. So f will be replaced by f by 2, f by 2, then it will become j 2 pi f, f by 2, and here 1 by 2, and if you will add minus sign, here we have to minus sign. Minus 1 by 2 x of f by 2 e raised to power plus j f by 2, so it is the answer of B, plus j 2 pi f. The answer is B. Which one is giving the answer? A. Everybody is giving the answer A. बहुत ही easy था question. Sonu Kumar, it is not that much of tough question. Answer is B, right? Kavita, are you getting my point? B, yes. Now everybody giving the answer, right? Tank J, correct. Now for the next question in front of you. Can anybody give me the answer for this question? A real valued signal x of t limited to the frequency band mode of f is less than equal to omega by 2 is passed through a linear time invariant system whose frequency response h of f equal to e raised to power minus j 4 pi f when mode of omega is less than omega by 2 and 0 otherwise. The output of the system is A, B, C, D. Can anybody give me the answer? Very good. Abhishek Sharma, are you getting my point? Jadev is giving the answer B. Kavita again. Kavita Kumari, beta jaldi mat karo. Soch samajh ke answer do, right? Ajay Kumar, very good. Smriddhi Soni is giving the answer xt minus 2. Okay. Let me check. What is the answer for this question? Dinesh, hello. So, mere doston, if you want to solve this question, it is a very easy question, not that much of tough question. First, what is the h of f? H of f is looking like this. In the frequency domain, if you sketch it, mode of it will happen between what? Only minus omega by 2 to omega by 2, right? Okay. If you will multiply this function, and this x of t is also limited to this frequency only. So in this frequency only the multiplication will take place. So if you will multiply if x of t having the frequency x of f, and if you will multiply with this in the time domain, you have to convolute in the frequency domain, you will multiply x of f with e raised to power minus j 4 pi f. So there will be the two time of shifting. Here the minus, so in the time domain we have to use plus. बताया तो था, टाइम डोमेन माइनस तो उसमें प्लस होगा, और प्लस किस में दे रखा है, कोई डी बोल रहा है, कोई सी बोल रहा है, जिसका जो मन कर रहा है वो वही बोले जा रहा है. द आंसर इज नथिंग. व्हाई यू आर गिविंग द आंसर? आई एम नॉट गेटिंग यू आंसर. व्हाई यू आर गिविंग द आंसर डी? It is in the frequency domain, it is multiplied na. So in the time domain we have to shift. So in the frequency domain here the minus sign. So in the frequency time domain we have to use plus. Yes Kavita. So answer is C is the correct option. अब देखो छोटे छोटे से क्वेश्चन में बेटा जयदेव, और इसमें तो बहुत सारे आर्थ जू ने ए दे दिया था, अभी ऑफिशियल ने डी दे दिया था. एवरीबडी गिविंग आंसर अकॉर्डिंग टू हिमसेल्फ, राइट. हो सकता है मैंने भी गलती कर दी, एक बार फिर से चेक कर लेता हूँ. एक्स ऑफ टी नीट फ्रीक्वेंसी ओमेगा बाय 2 के बीच में है, उस रेंज में है. टाइम इन्वेंट सिस्टम है, इसको आपको टाइम डोमेन में कॉन्वोल्यूट होगा, फ्रीक्वेंसी डोमेन में मल्टीप्लाई होगा, माइनस है प्लस आएगा. सी इज द करेक्ट ऑप्शन. यस शिवा, व्हाट हैपेंड इन द फ्रीक्वेंसी डोमेन? इफ यू विल मल्टीप्लाई, then only, because in the time domain we have to give the function. So time domain convolution give the frequency domain multiplication. That's why we are multiplying this signal. That's why we are using t plus 2. Right. Now for the next question. Okay, that's over. By this question, I think you are able to solve the few questions related to the Fourier transform, right? And I'll give you one more question as a homework to you. Can anybody give me the answer for this question? Minus infinity to plus infinity sin t by t dt. Can anybody give me the answer for this question? And this is as a homework to you, right? I'll give you the answer. The answer is nothing, it is just a pi. Complete integration process we have to solve, right? And here one thing more, a Vision 2021 course we are running, that is the complete coverage of the ESE prelims and mains and GATE syllabus, right? So that is the complete course of the GATE and the ESE. All topic covered through the live classes, study notes and conventional assignment. Faculties are from the IITs or ISC and the top faculty of the Indian Institute. Tripti, we are multiplying the negative power which will give x of t minus 2. Oh, once again let me check. Yes. Tripti, your answer is correct. Okay. It time domain shifting now, so it is the time domain. Yes, that is the not correct option. Yes, everybody is giving the yes, right? In the time domain plus, so in the frequency domain, time domain if minus, then, or if it is a minus, then only the minus is appeared. Okay, again I am taking my word back, because it is actually the time shifting property. It is not a frequency shifting. I thought it is a frequency shifting. That is skipped from my mind. It is a time shifting actually. Yes, Tripti, thank you. It is a time shifting. So time domain में minus है तो इधर भी minus आएगा. So yes, answer C is not correct. Answer D is the correct option. Yes. Right. Thank you, Tripti. Answer D is the option correct. Yes, Parshay. Answer D is the correct. Right. Right. Shiva Prasad, answer Fourier transform please थोड़ा बता दीजिए. बेटा क्लास खत्म होने के बाद संजय एक बार फिर से वीडियो को देखना. मैंने फोरियर ट्रांसफॉर्म की प्रॉपर्टी को पूरा डिटेल में एनालाइज किया है. राइट. Energy of the sampling is pi. And what about the area? Area is also pi, right? Abhishek. Okay. And one thing more, that is the scholarship test for the NIT, IIT and government college student and who already cleared the GATE exam, having the 50% discount in the Vision 2021 course. And more inquiry you can call 9650052940 on this number. And mail us on the help@gradeup.co and anand.pandey@gradeup.co, right? This number is basically help for you, right? And till that, thank you. टेंशन नहीं लेना दोस्त, जो टेंशन ले रहे हैं मैं उनको बता दूं, टेंशन लेने से कुछ नहीं होगा. जिंदगी में बहुत कुछ आगे देखना है और ये तो गेट जो है ना वो एक स्टेप है, सिर्फ स्टेप है. जिसको क्लियर करना है तो आगे की जिंदगी थोड़ी सी आसान दिखाई देगी. क्लियर मेरी बात? तो ज़्यादा टेंशन लेके जिंदगी में मत रखो कि यार अब जिंदगी कैसे चलेगा, गेट नहीं निकलेगा तो क्या होगा. मन में कभी किसी चीज़ को हावी मत होने दो. ये एक एग्जाम है, इसको बस एग्जाम की तरह लो. और एग्जाम की तरह कैसे लेंगे? बस सीधा आप बस प्रिपेयर करिए, बिना किसी टेंशन के, बिना फल की इच्छा किए हुए एग्जाम को दीजिए और हमेशा वो एग्जाम अच्छा ही होता है. अगर आप रिजल्ट को पहले से एनालाइज करने की कोशिश करोगे तो हमेशा आप टेंशन में रहोगे। तो रिजल्ट मत सोचो, बस कर्म करो, फल की चिंता छोड़ दो। फल ऑटोमेटिक, अगर आपने कर्म अच्छे किए तो फल तो अच्छा मिलेगा ही, राइट। और ऊपर वाला सब देखता है, मेहनत का फल बेचा कभी बेकार नहीं होता है। हमेशा एक चीज का ध्यान रखना कि मेहनत का एक भी फल, मतलब आपने अच्छे से भी मेहनत करी है तो कभी जिंदगी में ऐसा हो ही नहीं सकता कि आपको उसका रिजल्ट ना मिले, राइट। बिल्कुल बेटा, मन में विश्वास रखिए। टिल दैट थैंक यू, और मुझे पूरा विश्वास है यार आप एग्जाम फोड़ दोगे बेहतरीन तरीके से, पूरा विश्वास है मुझे, राइट। टिल दैट थैंक यू वेरी मच, ऑल द वेरी बेस्ट, राइट।